So we have two types of differential equation, ordinary and partial. Ordinary means there exists single independent variable, whereas in partial there may exist more than one. So what is order and degree? Order means highest derivative that you are seeing in that differential equation. So in this example, highest derivative is second derivative, so order is 2. Degree means power of the highest derivative. So in the example, see, you have second derivative, third derivative and first derivative. So highest is third derivative. So order is 3, degree is power of that. So power of that is 2, so degree is 2. Degree is always positive integer, not 0 or negative or fraction. So see in this question, we have order is 4 and degree is not defined because it is involving trigonometric function. And in second one, the order is 2 and degree is 1. And by seeing this question, you may think degree is undefined, but no, it is defined. We have to check once. See, if we are doing squaring on both sides, then the root is getting disappeared. So now order is 2 and degree is also 2. So remember, degree of differential equation doesn't exist when the coefficient involving exponential powers, logarithmic terms and trigonometric functions. So first we should learn some basic topics, which is like formation of differential equation. So how do we form? We have to eliminate the arbitrary constants. For example, this is the question. Y is equal to alpha x plus alpha square, where alpha is arbitrary constant. And now you have to find differential equation. Then what do we do? First we differentiate one time with respect to x. Then what do we get? X. So we get here alpha and this will be 0. So we got alpha value as dy by dx. Now we substitute this value and we get the differential equation. So y is equal to x into dy by dx plus dy by dx square. It is the required differential equation of order 1 and degree 2. So this is how you form differential equation by eliminating the arbitrary constants. Let's do one more question. So y is equal to this. So first we differentiate with respect to x. So e power. So first this e power. So we'll do uv like this. Cos x differentiation is minus sin x plus sin x differentiation is cos x. Now we'll write this a cos x plus b sin x. E power x differentiation is e power x only. So now I can write like this, minus a sin x plus b cos x. What is this? This is my y itself, right? So I'll write y. So now I have two arbitrary constants a and b, so I have to do 2 times differentiation. So now again I will do differentiation. So again uv. So sin x differentiation is cos x, so minus a cos x. Cos x differentiation is sin x minus sin x. Okay, next uv dash plus vu dash, so minus a sin x plus b cos x. E power x differentiation is e power x only, plus y differentiation is dy by dx. Now see, if I take here minus common, it will be nothing but y, right? So I can write it as minus y, this term. Okay, minus y. And next, see this term, which is nothing but this term, right? So I can write it as dy by dx minus y. Okay, so dy by dx minus y, and this term, which is nothing but 2 dy by dx. This will be, so we got, see, easily we eliminated the constants. So therefore final answer will be d square y by dx square minus 5 minus 2 plus 2y minus 2 dy by dx is equal to 0 is required differential equation of order 2 and degree 1. So this is how you eliminate the arbitrary constants and find the differential equation. This is some tricky question. So here constant is c, arbitrary constant. We have to differentiate only one time because there is only one arbitrary constant. We can't differentiate this 2 times. So we'll see how to do. Y dash is equal to 2c into x minus c. Next, I want to find value of c. So there is no other option other than dividing it. So I'll divide y by y dash. So what I'll be left with, x minus c by 2, which is x by 2 minus c by 2, or I can write it as 2y by y dash. So c is equal to, okay, so I got my c value. Sorry, c will be x minus 2y by y dash. Now I'll put c value, I'll get the equation. See, x minus, so this got cancelled, minus became plus, so this is how I am left. So y is equal to x into, so I'll take y dash cube as LCM. So I'll get here 4xy y dash minus 8y cube by y dash cube. It's already done, we are just simplifying it, that's it. So I'll bring y dash cube this side. So this, if I bring y this side, it will divide, so that will become 4x, this is y square, no? So now it will become 4xy into y dash minus 8y square. So this is your final answer. Square. Okay, first, how many arbitrary constants we have? 2. So we can differentiate this 2 times. So first I'll differentiate with respect to x. So we'll get x into dy by dx plus y into 1. Okay, uv. This side, a is constant, e power x differentiation e power x. This one minus b e power minus 2x. Okay, so we'll differentiate again. First uv for this two, so x into d square y by dx square plus x differentiation is 1, so dy by dx into 1. Next, this differentiation, dy by dx, this side a e power x only, this side plus b e power minus 6, and this 2. So clear, this is nothing but xy minus x square. So it's done. See, is equal, so is equal to x square, xy minus x square plus 2. So this is your required differential equation of order 2, degree 1. And see this is the question, we have to find d. So I wrote log y minus log x is cx. So if I differentiate with respect to y, I'll get 1 by y, and inner derivative of y is y dash. Log x derivative is 1 by x, and here c into 1. So I got c value. So now I'll put in the question. So log y by x is equal to y dash by y minus 1 by x into x. Okay, so this get cancelled. So what will be left? X by y into y dash minus 1, or I can write it as 1 plus log y by x into y by x is equal to dy by dx. This is the formation of differential equation. And if question is this, we have to find differential equation. Arbitrary constant is 1, so we have to differentiate only one time. So for this, 1 by root over 1 minus x square, and for this 1 by root over 1 minus y square into dy by dx, right? With respect, we are differentiating with respect to x, so we'll get dy by dx. This side constant, so 0. So now I can write it as into dy by dx. We'll take that side of the equation, so this will become minus 1 dy by dx. So if I cross multiply, this will be dx by root over 1 minus x square is equal to dy by root over 1 minus y square. Finally, if I want, I can write it as dy plus dx is equal to 0. So this is my final answer. So see next question, y is equal to a tan inverse of x plus b. So differentiating with respect to x, I'll get 1 by 1 plus x square, and this will be 0. From here, what is my a? Is y dash into 1 plus x square. So because I have two arbitrary constants, I can differentiate it 2 times. So 0, this will be y double dash into 1 plus x square, uv formula, plus 1 plus x square differentiation is 2x into y dash. So y double dash plus x square y double dash plus 2xy dash is equal to 0 is your differential equation. Here directly we got easily. So where r comma theta are there, they're like x comma y. So here arbitrary constant is a. Okay. So we have to differentiate only one time. R differentiation is 1 and here 0. Cos theta differentiation is minus sine theta. Because with respect to r, so this will become d theta by dr. You can do anyway with respect to r or with respect to theta. Okay. So now a value we got as, so 1 by sine theta cosecant theta. So minus cosecant theta dr by d theta. So now we will substitute a value in question. That's it. So r is equal. So this is your differential equation. So we eliminated a by like this. Now until now we have seen formation of differential equation. Now we are seeing solving. How we will solve. So how we formed by differentiating. How we will solve by integrating. So there are most probably two methods: variable separable and equation reducible to variable separable. So we will see how to do. See, if you can see that variables are easily getting separated, then we will use this method. Okay, and this side I differentiated my variables like this. I separated my variables like this. So now integrating both sides. So now see, now this formula is very important. F dash of x by f of x. What is the formula? Log mod f of x. And the formula we have is f dash of x by root f of x, which is 2 root f of x, which we have already learned in inter, very important formulas. So now see, y plus 1 integration is 1, but I have y here, so I will create it. Okay, here e power x integration is e power x. This is good, but here I created. Okay, so now what I will do? So integral y plus 1 by y plus 1 minus 1 by y plus 1 is equal to, this side I can write directly log f of x, which is e power x plus 1 c. Okay, now this is integral of 1. So integral 1 dy is y, and this is f of x by f dash of x. So log mod f of x, which is y plus 1, and this side it is log e power x plus 1. I can write it as log c. Constant can be log c also. So my solution y is equal to, if I send it side, I can write log a plus b plus c. So log abc. So I'll write y plus 1 e power x plus 1 into c. So this is your answer. This is solving differential equations. Okay. So in this question, I separated x and y. So now we're applying integration. So e power x differentiation is e power x. So integral f dash of x by f of x is log f of x. So this side log f of x. This side, what is derivative of tan y? Secant square y, right? So this is also log tan y plus c. So if I want, I can write it as log of e power x minus 1 by tan y is equal to c. Okay, so this is how you find the solution. So see this question, we cannot separate x and y. So in these cases, this is case 2. I told you, equation reducible to. So in this case, we should take substitution. Let u is equal to x plus y. Then I will find differentiation. Du by dx is equal to 1 plus dy by dx. So now I'll substitute. So dy by dx will be du by dx minus 1 is equal to tan square u. Okay, so I want du that side. So if you see here, du by dx will be secant square u, because tan square u plus 1 is secant square u. And now, so now I will apply integration. So I told you cos square u formula, 1 plus cos 2u by 2. So now integral 1 by 2 du plus integral cos 2u by 2 du is equal to x plus c. And now this will be u by 2 and integration of cos 2u sine 2u by 2, so by 4 is equal to x plus c. We should not forget to substitute u. Is x plus y by 2 minus x plus sine x plus y by 4 is equal to c. This is your final answer.